Hey everyone, in this lesson we are going to talk about the junction box in the PV panels. So if you look at any PV panel, you can see we have the front of the PV panel with its own width and length, and of course the thickness of the PV panel. Okay, this is the front of the PV panel. Now if you look behind at the back of the PV panel, you will find here a box. Here, this box. This box is known as the junction box. Now what does it contain? It contains the positive and negative terminals of the panel. So if you remember that any PV panel has two terminals, positive and negative. We have the two terminals which we are used to connect to another panel or to take the output power. Now if we look at this figure, you can see that here we are using a type of cables called MC4 connectors. The MC4 connectors, which you are seeing here, what are they used for? They are used to connect between two panels. Okay, we can connect them together to form a string, or in parallel, such as in a combiner box, and so on. Okay, so as you can see, we have two terminals, one which is a positive and negative, and then we start connecting the two panels. So you will find that inside the junction box there are diodes. Now what are these diodes? They are the diodes which we discussed before. So we'll find that we have two types of diodes in the PV system. Okay, remember that we talked about the bypass diodes in order to solve the problem of the shading effect. So remember, each part of the panel has a bypass diode. Okay, remember it. Okay, to bypass a panel if it has a problem of shade or has a shading effect. Okay, now you will find that there is another type of diode called the blocking diode. Now what does this diode do? It simply prevents the power flow from the battery to the panels. Okay, so as you know that during the day the panels are supplying electrical power to the battery to charge the batteries. Okay, now at night this panels does not produce any power. So if there is no blocking diode here, what will happen is that this battery will start giving electrical power to our panels, which will lead to burning of the panels. Okay, so we need a type of diode called the blocking diode in order to prevent the power flow from the battery to the panels at night. Okay, so what are the diodes inside the junction box? The diodes inside the junction box are one type, which is the bypass diodes. Okay, now where are the blocking diodes? The blocking diodes exist inside the charge controller, which is used to charge the batteries. Okay, inside it has the blocking diodes, okay, which prevents the power flow from battery to the panels. Okay, now if we look at the junction box here, this is our junction box. Okay, this part. Now if we look at it closely here, you will see that we have two terminals. You can see here positive, as you can see positive here, and you can see negative. So we have positive terminal of the panel or the junction box, and the negative terminal of the junction box or the panel itself. Now if you look at here, you will see that we have here the diodes, this diode and this one and this one. All of these, all the three are diodes. Okay, they are connecting between 1, 2 and 3 and 4 bus bars. Okay, we will see the equivalent circuit of this in the next slide, but for now you have to know that the junction box is an enclosure on the module or the PV panel where the PV strings are electrically connected. Okay, you will find that inside using this junction box we can connect the PV strings. Okay, since we have here one terminal positive, another terminal negative, and we have another panel like this with a positive and a negative terminal, so in order to connect them in series we will take this like this, positive with negative, and then positive with the next negative, and so on. Okay, so we will have in the end two terminals as we discussed before. Okay, when we learned how to connect strings in or panels in series. Okay, so by using the junction box, the two terminals, we use them using MC4 cables or connectors. We can connect between panels in order to form strings. It's found on the back of the solar panel. It wires usually 4 connectors together, and it is out interface of the solar panels. So as you can see here, what does this mean? You can see 4 connectors. You can see 1 and 2 and 3 and 4. So this junction box connects between 4 bus bars. Now what does this even mean? You will understand in the next slide. When buying the solar modules, we have to look at the IP or the ingress protection of the junction box, or it representing the protection. 2 numbers, one representing the protection against liquids and the other representing the protection against the mechanical stress. So you will find that 2 number 67, IP67 is a very high IP or ingress protection. This value, it means that this junction box is well protected against water coming from rain, for example, and protected against the mechanical stress. Okay, now you have to know that most of the photovoltaic junction box have diodes, which is the as we said before, the bypass diodes. Now the bypass diodes, we said that it is forming as a shunt path to allow current to bypass the faulty or underperforming module. So if there is a fault inside the part of the panel, or there is shading effect, it will bypass this panel or this part of the panel. Okay. There is another type of diodes which is found where inside the charge controller, which we are going to discuss. This diode or the blocking diode prevents the current from flowing back through the string, discharging the battery at night or other times when the solar panels are not working. So in the end, it prevents the power flow from the batteries to the solar panels. Okay. Okay, so let's see closely how it looks like. So this shape here is similar to this one. Okay, so you can see we have the, what is this diodes? The bypass diodes. Okay, now if we look at this figure, which we have discussed before, you can see we have how many diodes? 1, 2, and 3, right? If you look here, we have 1, 2, and 3. Now you can see that here we have this one and this one. Each diode takes 2 rows of the cells. Okay, so 1 and 2 and 3 and 4, 5, 6 rows. Okay, so you'll find that we have one line here, second line, where is the third one? We have one here, one here, and one here, and one here. Okay, so if you look carefully here, you can see that the first diode connects between 2 bus bars. Second diode connects between this bus bar and this bus bar here. This diode connects between 2 bus bars. So to make it more clear, okay, if we look, we have 1, 2, 3. Okay, so we have 1 and 2, 3 and 4. Okay, so it connects between 2 bus bars or 2 lines of string here cell strings, and here two strings. String here means a string of cells. Okay, so you can see we have 1 2, which is the first part, and 1 2 second part here, then 1 2, which is the third part. Okay, so this representing the equivalent of this. Okay, and of course, as you can see, we have two terminals like this terminal and another terminal here. You can see here we have terminal here and another terminal here. Okay, so I hope this configuration is clear for you now. So here the same idea, you can see we have the bypass diodes. Here we can say this one is a conducting strip, or the one which is related to each string. Okay, so this type, for example, has only two diodes, which means we have only something like this. Okay, we have a diode like this and another diode like this. Okay, and under them we have group of panels here and group of panels here. So it divides the panel into two strings or two lines. Okay, then we have finally the positive terminal and the negative terminal, which goes to the charge controller and the battery. Okay, here is the same idea. You can see here, you can look at here, you can see the positive. As you can see here, this is how it looks like the positive, and the negative looks like this, or male and female. Okay, here you can see positive, and we said before that positive is usually the red one, and the negative is always the black one. Black one is usually related to the ground. Okay, and the positive representing the live part of the electric circuit. Okay, so when wiring module strings together, which happens in series, positive to negative, the voltage is increasing while current stays constant. While wiring multiple modules strings together in parallel, positive to positive, negative to negative, current is increasing while the voltage stays constant. Okay, so if you remember, what does this mean? If you remember, we said that in order to connect, in order to form a string, what will happen in this case? We are connecting the modules in series. In series, which means that we are connecting positive with negative, and the next one we have positive connected to negative, and we have positive connected to negative, and so on. So we are connecting them in series, positive to negative, like this, which increase the total voltage but keeping the current constant. And we said that when we have strings and we would like to form an array, which is group of strings parallel to each other, we need to connect positive with positive like this, and the negative with negative. Then we take to this terminal and this terminal to have our panels. Okay, the idea of connecting to positive, negative to negative, so as if they are, or not as if they are in parallel. Okay, now let's see how does a PV panel junction box looks like. Okay, so if we run this one like this, if we go like this, if you open the junction box of any panel, any PV panel, you will find that here, like this, you will find that we have 1, 2, and 3 diodes, right? We have 1, 2, 3 diodes. Usually you will find here two terminals. You can see this here and here. Okay, so you can see that here, this one usually is a positive and this one is negative. So how can I know this? Okay, so this circuit is similar to the one which we discussed before. We had 3 diodes and 3 strings. Okay, so in this figure you can see we have the terminals here, but which one is the positive and which one is the negative? So how can I know this? Using the avometer. So you will do something like this. You will go here and take the red one, which representing the positive, and the black one, which representing the negative. So we will start adding this to this point and connecting this on this point like this. Okay, you can see that the voltage here is 17.42 volt. It means that this is actually the positive and this one is the negative. Okay, we are connecting correctly. Okay, so if this value is negative, it means that we have the reverse. It means that this one is the positive and this one is the negative. Okay, so the red one is connected to the positive and black one connected to negative. If we done the connection correctly, then you will find it here positive. If the connection is wrong, you will find it negative. Okay, so as you can see, we learned here we have positive and negative. So what we are going to do, we are going to add two indicators to help us know or remember that this one is a positive one and the other one is the zero or the ground one or the negative terminal. Okay, then what is the next step? Then we are going to remove this and then we are going to add our wires. So as you can see here, like this, we have the two wires like this. Okay, then we start connecting the red one with the red one and the black one with the black one. Okay, you can see like this to keep it in its place, like this. Okay, take the red one and put it here like this. Okay, so we will first like this. Yes, we will see this one in the next lesson, don't worry. Okay, so let's move a little bit like this. You can see we removed this part, then we connected it to the red line so that we can fix it here. Okay, like this, as you can see. Then we are going to do the same thing for the ground one or the black one. So as you can see, we have this two are fixed. Okay, we have the positive and negative of the, then we close the module like this and then we are completely done. Okay, so as you can see here, as you can see, connected here and connected here. So in this lesson we learned about the PV junction box and we learned about the wiring of junction box.